The moment of a force with respect to a point measures the force's ability to rotate a rigid body around that point. It is defined as the vector product between the position vector from the point of force application to the reference point O and the force vector. The moment is represented by a vector perpendicular to both the force and position vectors. The formula for calculating the moment of a force with respect to a point is as shown on the screen, where r is the position vector between the point of force application and point O. F represents the applied force. The magnitude of the moment vector can be calculated using the following formula, where d is the minimum distance between point O and the line of action of the force. Theta is the angle between vectors r and f. The moment is measured in units of Newton meter or pound foot. The calculated moment is a vector perpendicular to both r and f. The sign of the moment indicates the direction in which the force tends to rotate the rigid body. A positive moment implies counterclockwise rotation, while a negative moment implies clockwise rotation. Similar to the vector product, the moment of a force can be expressed in terms of its rectangular components. The formula for calculating the moment of a force with respect to a point using rectangular components is given by the determinant of the following parameters, where mx, my, and mz are the components of the moment on the xy, z axis, respectively. Fx, fy, and fz are the components of the force on the xy, z axis. Rx, ry, and rz are the coordinates of the point of application of the force with respect to the reference point. This decomposition allows us to analyze the moment of a force using individual components, which can be useful for certain types of problems.